Now here the question is, we need to prove that y equals this function is the equation of a straight line parallel to x-axis. Now we know that for any line which is parallel to x-axis, y is constant. Now in order to prove that it is a straight line parallel to x-axis, we know that equation is y equals c, or derivative of y with respect to x is simply 0. For this equation we write dy by dx as sin inverse of sin x, and then derivative of sin x is 2 sin x into cos x, and then plus here it will be cos inverse of cos x into 2 cos x and minus sin x. Now sin inverse of sin x is x and cos inverse of cos x is also x. So we'll get this as x into sin 2x minus x into sin 2x, which is 0. So that means for this function dy by dx is 0. And if dy by dx is 0, it is a constant function. Now you have to find the value of y. What we'll do is we'll find this value of y at any convenient value of x. For this question, the convenient value of x is pi by 4. So we write y equals this integral from 1 by 8. Sin pi by 4 is 1 by root 2, and square will be simply 1 by 2, and here will be sin inverse under root t dt, and here also we write from 1 by 8 to 1 by 2 cos inverse of under root t dt. Now limits are same. Sin inverse x plus cos inverse x is pi by 2. So we write y equals this integral from 1 by 8 to 1 by 2 will be pi by 2 dt. So we'll get this y as pi by 2 into 1 by 2 minus 1 by 8. So it will be pi by 2, and this is 8. This is 4 minus 1, and it should be 3. So value of this integral will be 3 pi by 16. So equation of this line will be y equals 3 pi by 16. Now here the question is, we are given a function fx which is 1 upon x square into this integral from 2x 4t square minus 3 f dash t dt. Now we need to find the value of f dash 4. So we'll differentiate it. We'll write f dash x, and it'll be 1 upon x square. Now in this case limits are variable, and here it is a function of t, so there is no parameter x. We'll use Leibniz Integral Rule. We can write this as 4x square minus 3 f dash x into derivative of upper limit, which is 1, and then minus, since lower limit is constant, its derivative will be 0. Now plus this integral 1 to x 4x square minus 3 f dash t dt into derivative of 1 upon x square, and it'll be minus 2 upon x cube. Now this integral, it is nothing but x square into fx. So we can write f dash x, and it'll be equal to 1 upon x square 4x square minus 3 f dash x, and then plus, and here will be x square into fx. So x square and x cube will cancel, so we'll get this as minus 2 upon x into fx. Now we need to find the value of f dash 4. So we'll put x as 4, and if we put x as 4, we'll get this as f dash 4, and it'll be 1 by 16, and here will be 4 into 4 square, which is 64 minus 3 f dash 4 minus 2 by 4 into F4. Now what is F4? F4 will be 1 upon 4 square and then this integral from 4 to 4. So when we have same limits, value of integral is 0. So that means this is 0. Now we can write this as 16 f dash 4 and L be equal to 64 minus 3 f dash 4. So from here we can write f dash 4 as 64 upon 19 and that's your option C. Now we are given this equation which is integral from sin x to 1 t square ft dt and L be equal to 1 minus sin x for all x belongs to 0 to pi by 2. Now we'll need to find the value of f 1 by root 3. Now what we'll do is we'll differentiate this function. Now we'll put upper limit and then derivative of upper limit is 0. So it'll be simply 0 minus lower limit. So it'll be sin square x into f sin x into derivative of sin x is cos x and L be equal to 0 minus cos x. Now minus and minus will cancel. Cos x will also cancel. We'll get f sin x equals 1 upon sin square x. Now if we take sin x as t, we can write ft equals 1 upon t square provided t belongs to 0 to 1 because x belongs to 0 to pi by 2. Now we need to find the value of f 1 by root 3. Now 1 by root 3, it belongs to this interval. So we can write f 1 by root 3 as 1 upon 1 by root 3 square, which is nothing but 3. So answer to this question is 3 and that's your option A. Now here the question is if fx is differentiable and this integral from 0 to t square x fx dx, it is 2 by 5 t to the power 5, then we'll need to find the value of f 4 upon 25. Now what we'll do is we'll again differentiate this function with respect to t. So we'll get t square into ft square into derivative of upper limit which is 2t minus derivative of lower limit is 0 and it'll be 2 by 5 and then 5 t to the power 4. Now 5 will cancel, this 2 will also cancel and this t cube will also cancel. So we'll get ft square as t. Now we are given f 4 by 25 and we can write f 4 by 25 as plus minus 2 by 5 whole square. So it'll be plus or minus 2 by 5 and we are given this plus value which is your option A. So value of f 4 by 25 is 2 by 5. Now the next question is this integral from 0 to x ft dt, it is x square plus this integral from x to 1 t square ft dt, find the value of f dash 1 by 2. Now what we'll do is we'll differentiate this equation with respect to x. So we'll use Newton-Leibniz rule. So it'll be fx into derivative of x is 1 minus derivative of 0 is 0. Now derivative of x square is 2x and then plus, and here again we'll use Leibniz integral rule. Now 1 is constant, so derivative of 1 is 0 minus and then lower limit which is x square into fx and derivative of x is 1. So we can write fx equals 2x minus x square fx, or the value of fx is 2x upon 1 plus x square. Now we need to find the value of f dash 1 by 2. So we'll differentiate this function. So we'll write f dash x as 1 plus x square into 2 minus 2x into 2x upon 1 plus x square whole square. So we'll take this 2 common, and then we'll have 1 minus x square upon 1 plus x square whole square. Now we need to find the value of f dash 1 by 2. So we'll put x as 1 by 2. So if we put x as 1 by 2, we'll get f dash 1 by 2 as 2 into 1 minus 1 by 4 upon 1 plus 1 by 4 whole square. So it will be 2 into 3 by 4, and this is 25 by 16. So it will be 24 upon 25, and that's your option A.